Alright, today and tomorrow we're going to be talking about arcs and chords. And a chord is a segment with endpoints on a circle. A chord is a segment with endpoints on a circle. So here's a circle. And here's a segment with endpoints on the circle. Alright, so this segment AB is a chord. Now, this chord AB, arc AB, do you see how chord AB created this arc right here? Alright, it created arc AB. So that's called a corresponding arc. So you can say arc AB corresponds to chord AB. Just like if you had a different chord down here. Let's say down here you have a chord CD. Alright, as soon as you draw that chord into that circle, you create an arc. And in this case, this arc right here, arc CD, corresponds to chord CD. Okay? So there's a theorem on that page, on page 715, that says, in the same circle, or congruent circles, two minor arcs are congruent, if their corresponding chords are congruent. Two minor arcs are congruent if their corresponding chords are congruent. So here's a diagram of that. If you got a chord right here, chord AB, and a second chord inside this circle, chord CD, minor arcs are congruent if corresponding chords are congruent. So if you're told this here, that AB is congruent to CD, then arc AB is going to be congruent to arc CD. Oops. So you can write this in the form that if segment AB is congruent to segment CD, then arc AB will be congruent to arc CD. So if you're given and you'll be better off watching right now instead of trying to write this down. If you're given this picture, here's XY and it's 7, and then over here you've got chord AB and it's 7, and arc AB is 42 degrees, and you're asked to find the measure of arc XY. If you're asked to find the measure of arc XY in this circle, well, you've got chord XY congruent to chord AB. And if arc AB is 42 degrees, well then arc XY is also 42 degrees. So there it is, 42 degrees. Any questions on that? Look at the top of page 716. Here's another example of the theorem. You've got chord right here, NM, and another chord, PQ. In the book, they're in separate circles, but you're told that the circles are congruent. Now, with tick marks or arc marks, arc NM is congruent to arc PQ. And you're told that NM, segment chord NM, is 2x plus 1. And chord PQ is 3x minus 7. And you are asked to find PQ. Find PQ. So what you would need to do first is, if these two chords are congruent to each other, or I'm sorry, if these two arcs are congruent to each other, then their corresponding chords are congruent to each other. So your 2x plus 1 is equal to 3x minus 7. And then you can subtract 2x from each side. And 1 would equal x minus 7, and then you could add 7 to each side. So 8 is equal to x. So now if you need to find P to Q, you would take 3 and multiply it by 8 and subtract 7. And that would be 24 minus 7, which would be 17. So your P to Q would be equal to 17 units. Okay, what you got to get out of it is if the chords are the same, then the arcs are the same. And vice versa. If two arcs are congruent to each other, then the chords that form those arcs are congruent to each other. Take a look at the middle of page 716. And you've got Theorem 10.3 and 10.4. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So here we go in a circle. If we've got a chord right here, here's chord AB. If a diameter or radius is perpendicular to a chord, diameter or radius. So if I take a line, put it through the center, and whether it stops at the center or it keeps going all the way through, it doesn't matter. First part's the radius. If continued, it's a diameter. If these two intersect at 90 degrees, if a diameter or radius is perpendicular to a chord, so now here's XY, perpendicular to chord AB, it bisects the chord and its arc. So that means that this piece, if we call this point in here Z, then this point A to Z, or this segment AZ, is congruent to ZB. Diameter's perpendicular to a chord. It bisects the chord, and it bisects this arc right here. So AY would be congruent to YB. Gracias. Alright, Theorem 10.4 right there below it. Add this. The perpendicular bisector. The perpendicular bisector of a chord is a diameter or radius. Alright, down there on the bottom of page 716, example 3. In circle S, the measure of arc PQR equals 98. Find the measure of PQ. And here's your circle. Let's see, here's circle S. Here's a chord, P to R, or PR. Here's segment QS that is perpendicular. This is point T, and TR is equal to 6. PQR, 98 degrees. Arc PQR, that's from right here around to here, 98 degrees. Find P to Q. Alright, there's two things going on. There's three things going on. You've got this segment S to Q that starts in the center of the circle and it ends on the circle, and it's perpendicular to chord PR, which makes it a radius, which by rule, if it's perpendicular, it bisects the chord, so that makes P to T 6, and the corresponding arc. So since QS is perpendicular to PR, QS splits this arc in half. It bisects it. So P to Q is the same as Q to R, and they're both half of the 98. So there's a 49 degrees and another 49 degrees. So your measure of arc PQ is equal to 49 degrees. Y'all see that? Read the rule, apply the rule. It's all about corresponding chords and arcs, and it's about radius and diameter intersecting chords at 90 degrees. Okay? So the practice problems I want you to do today, we're going to start on page 718. One through 3. Seven through 14. And then 40 through 43. Make sure that assignment is 100% complete when you get to class tomorrow, and that you've checked all the odd answers in the back of the book.